give a I'll give a very brief just intro. Guys, welcome to our second community research call. We're extremely excited to have you here. These are our sort of periodic events where we share information about what's going on with Manifold research projects with the community. And so, without further ado, Hirsch, please take it away.
Yeah, sounds good. We can go ahead and go next. Next slide.
Mhm.
Yeah, so we have a lot to cover today. We'll do our best. I think we'll try to have some time for Q&A at the end of the session. But also, please feel free to send messages and in the chat. We will I think periodically be checking those, right, Sid, and then be able to respond. And we have a bunch of folks from Manifold in the core team who are here today. Um, and we also have like our names and communication information for each project and the various leads that you'll see throughout. So hopefully there'll be plenty of entry points to chat, get involved, follow up, that kind of thing. So at a high level, yeah, we're gonna cover a brief overview of our organization, like what we're trying to do, because I think it contextualizes a lot of these efforts. And then jump into these current project updates. So these are like active projects at Manifold today. Talk about new directions and new projects that are emerging and we're sort of starting to spin up, and then some various organizational updates that might be useful for people who want to attend not just events like these, but other sort of things that are happening on the horizon. Next slide, please. Cool. Okay, so I'm gonna be
All right.
I think yeah, I'm
Sorry
gonna be
about
quick
that.
about this. So Manifold, it started sort of as just a research collaboration amongst a lot of different colleagues at a bunch of different institutions, but now it's sort of morphed in the past half year to a year into a new kind of research lab. So we've really been thinking about, when you're what can you do to pursue advanced sort of disruptive research in various directions, like not limited to particular fields, that we're able to do with the technology and the coordination that's facilitated by that technology today. And so we are sort of trying to combine useful characteristics that we've learned from industrial research groups and open source orgs, academic labs, sort of all the great different initiatives that have existed in doing foundational and applied research. And where we've landed is that Manifold really pursues these large scale thesis driven projects. We do both top down projects and a lot of bottom up stuff, as you'll see. And we try to enable and accelerate those projects using sort of open source coordination and getting as many people involved as possible and building a much broader network than would literally have been possible before the 21st century. And we also sort of engage in a lot of structured collaborations and partnerships. And a lot of this stuff is growing really fast and changing rapidly. And so you'll see a bunch of updates about that today. And we don't think about this as like, you know, uh, something that's a 2 year experiment or something. We're trying to build a research lab and an institution that will persist and be able to pursue really long theses and really push a lot of these ideas forward. And importantly, we want to stay away from clashing incentives that drive too much sort of lack of focus in doing actual foundational research. But we also have to learn how to exist. And so one of the things that's emerging is for an organization like this, like how do you pursue this research? How do you get the resources you need? And one really cool thing is that as we start to pursue some of these crazy projects you're going to hear about that we're excited to share, we're also able to spin some of them out into whether nonprofit efforts or for-profit efforts that allow them to sustain and continue for a lot longer. So we'll share, and we have some exciting news on the spin-out front as well. Next slide, please. Super high level, what does the community look like today? And so we have a broader community of 530 people or something around abouts there. It's doubled in the past couple months, and is growing very fast. And this is a pretty high talent density community. There's a lot of like researchers, faculty, postdocs, research scientists from industry. And then we also have what we call the OS research team, which is people who work in sort of a dedicated part-time capacity. We're all volunteers, right? The way the lab is currently set up, and that's sort of intentional. But we meet synchronously, and a lot of the OS research team are leads on various projects. You'll be hearing from a bunch of them today. Let's go forward one slide. Another way that we've been trying to think through, making and realizing complex research more effectively is what are the lessons that have come from various other kinds of organizations. And so we've centered on some of these principles around the way that we engage with the world. And so, like, of course, everything is open. We target open source in essentially everything we do intentionally. But we try to ship research fast and iteratively, and that's challenging. So it's always evolving. But we're always trying to sort of ship research almost like a startup ships its products. We do everything in the open, so you'll see public roadmaps. Project tracking is even in the open, and that allows people who want to dive in to engage with us pretty granularly on the things that we're working on. Almost everything that we do is managed through Discord, and you can get involved in all the projects. The channels are open. We chat about them. You'll always see updates across these channels, and it's a great way to just chime in and jump in. And there's always core team members active there. And generally, we try to facilitate, lots of discussion and stuff here in Discord. We also have, these publications. So we run a biweekly publication covering not only the exciting things that we're doing on a biweekly cadence, but also what's happening in the world of usually focused on AI, but more broadly, sort of fundamental research and the exciting things that we're tracking, and we share them. And that's called the research log. And then finally, we've just kicked off this event series, which we call Community Research Calls. So this is number two. The first one happened in April, and it's just a great way to engage with the world on the things that we're doing. Next slide, please. Yep, I'll be quick here. As you can imagine, like because we take these long theses and we care a lot about what the nature of the research we're doing is, we think a lot about how do you drive impact from all the way from sort of the beginning, initial ideation stages around new research projects and questions that emerge across various fields, mostly in AI, because that's where our sort of core competency is, all the way through to realizing sometimes those projects mature to a level, or there's certain incentives for them to be able to exist and pursue their goals at a larger scale. And so we think a lot about capturing value. We call it sort of pedantically capturing value beyond papers. But what we really mean is like, how do you enable these projects to achieve their impact in the most value generative way for mankind as possible? And how do you engage with the world in the most effective way to accelerate that vision? And the other, I think, notable way that we think about things is that we have a very thematic way of looking at research problems as well. So we kind of think not just in terms of specific projects, but also in research directions, broader sort of themes, and that allows us to think about the impacts these projects have on each other and how they feed into each other. And you'll see a lot of that in the research project we talk about today. Next slide, please. Just a brief taste of where we're headed. Ton of new research directions emerging. If you had attended our last CRC, we're mainly working in multimodality and some initial thinking around agents. We're already branching now into we have some active projects around robotics. Starting to spin some efforts up in biology and applying AI to bio. And we also have spun out a startup actually that sort of has become a sponsor and collaborator for some of our projects, which you'll hear about in a second. So, um, yeah, and we kind of think of ourselves in the center of this ecosystem between all these different parties, right? Like funding agencies, whether that's sort of philanthropic funding, government funding, engaging with the world through sort of productionizing our research in the form of these spinouts for it to live on, and also interacting, as effectively as possible with as many open source groups, as many academic groups. So yeah, that gives you a taste of the way that the group is forming. Next slide, please. Cool. So we're going to jump into active project updates. I think the first one is Multinet. So Pranav, if you joined the stage, the floor is yours.
Awesome. Can you guys hear me?
We can. Yeah.
Awesome. Yeah. If you can go to the next slide, please. The next one again. Yeah. First of all, hey everyone. Thank you so much for joining, taking out the time, on your Sunday and joining us. Pretty exciting to update all of you on what we've been working on. Multinet specifically is a project we've kind of been like heads down on the last couple of months or so. So I'll start off with like kind of a high level overview of like why we started with Multinet what it is and where we're going with it. So really, like we were, the start of this is kind of like inspired by these class of models that are called vision language action models, and it kind of goes back to DeepMind's Gato, which was like a couple of years ago, where it was trained on not only language, vision, and vision language, but also this entirely new modality of control data, which is, reinforcement learning and robotics data as well. And much more recently, especially because Google Research kind of open sourced, the largest offline reinforcement learning data set, there have been a lot of exciting, research efforts in this direction of VLAs, especially with OpenVLA, Octo. But the thing with these, both of these models are that they're optimized for the objective of doing really well solely on the control tasks, be it reinforcement learning or robotics. And with Gato, I guess, it was not really open sourced. There was not a lot of like follow up research on it or like any showcase of like its downstream capabilities. So we were inspired by this class of models, and we landed up on this thesis that if we can train a large foundation model on web scale multimodal data, vision language, the association of vision language, and at the same time also reward based action trajectories, which is basically what reinforcement learning and robotics data is. We think that this will result in like an entirely new class of foundation models, that can go beyond just content generation and modification that the current class of foundation models are, and they can actually deliver on the promise of like completing actions and long horizon planning tasks, where they basically have to, reach a certain goal by interacting with a specific environment. And all of this is incentivized by some sort of like reward system. So this is kind of our inspiration and thesis. Uh, the first like set of goals that we're working towards, and we've made a lot of progress on for multinet, is we do want to consolidate and provide in a very easy way for people to use, like the largest open source vision language and control data set. Uh, and also, like once this data set is available and people are able to access it, train their own models, or do whatever exciting research it is on these data sets, we also do, and we are like working on kind of building a benchmark around this. So basically, a benchmark that kind of evaluates really how well the current state of the art models do in these, across a variety of these tasks, modalities. Are they truly generalist, or are they, optimized for a specific set of tasks and modalities? And we want to showcase to the field that, like if these models do well on that benchmark, that's amazing. But if they don't, there's a lot of room for research in this direction, and we truly believe that by training on like this new paradigm, these new like uh, classes of data sets, we do think that's an entirely new like research direction in like foundation AI technology. So we do want to have a challenging benchmark for these vision language action style models, and we do want to profile the current state of the art models and showcase their generalist capabilities. And yeah, so the way we kind of like started going about this is actually it said if you can pull up the datasets deep dive doc.
Yeah, let me go ahead and do that now. So data sets, deep dive.
Yeah, this one. So this is slightly outdated, but it kind of shows like our thought process about how we went about it. So even though Gato had used like this large data set of like vision language and control, a lot of them were closed source, and also in a way outdated because this was 2 years ago, and there's been a lot of advancement in both control and vision language since then. Much bigger data sets, much more diverse tasks, and a lot of open source as well. So we kind of like dive deep into what each of these data sets were, and like what training on them would really unlock. And we started like finding open source alternatives for each of these data sets. And not only did we find alternatives, we kind of went beyond and we said, okay, can we like build a much larger open source data set with, you know, a much wider variety of like tasks and better task distribution. So that's kind of how we went about it. This doc is, you know, everyone can access it. By the way, it's just kind of shows our thought process about it. For example, like, you know, they used massive text. We don't use Pile now, but yeah, actually, like the final dataset list we landed upon is Seth. Can you switch to the scoping tab? Yeah. So this is on one of our closed issues. So if anyone's interested, they can do it. But we kind of landed upon this final list of data sets after this specific data set deep dive and research. And for vision language, we have about eight, and for control, we have about I think 11 or 12. Um, so another thing is also that when we were like doing this data set deep dive, this uncovered a few like newer research problems. So one is that we realized that in control, especially, uh, a lot of these reinforcement learning and robotics data sets are provided by, you know, various different parties. Some of them are not really maintained too well, and they're all of various different formats. You know, TensorFlow, PyTorch, Hugging Face has its own format. There's another format called Minari. So they're not really unified, not very easy to use, not very easy to access. So another thing that we wanted to do with this kind of consolidation of source data sets is that we also wanted to provide, you know, an easy way for people to kind of translate all these control data sets to like a unified format. So one easy format that you know, basically you can load, train on, do whatever it is that you'd like to do with it. Can we go back to the slides, please? So yeah, yeah, cool. Yeah, so that's kind of like the final list of data sets that we landed upon, and where we're at right now is we've made a lot of progress, very exciting. We have actually, you know, internally consolidated this entire V data set that, you know, all the different data sets that are in our V0. Um, they come up to, you know, around like 70 terabytes, several trillion tokens, all of them fully open source. And the best part is it's across like, you know, a wide range of categories, like whatever it is, you know, any different types of vision language data sets. And even within control, we have like navigation based control, locomotion based control, manipulation based control, game based control. So this is like Atari, Mojoko based tasks, and, you know, different kind of robot embodiment manipulation tasks as well. And we've also open sourced kind of a simple code base uh, that allows anyone to, you know, download any or all of these data sets. You could download all, you just need to make sure you have sufficient storage. But basically, you can download any of the data sets in our V0 list, and also very easily translate any of the control data sets that you download through our downloader script into this specific unified format. So this specific unified format that we kind of landed upon was, you know, TensorFlow datasets. You can, you know, we always build in public. We're always thinking through a lot of our research decisions, and you know, any thought processes around like this entire project. You can see in our multi-net channel, and we've had a few discussions about, you know, what format do we kind of land on, what do we unify it to. So we ended up with TensorFlow datasets because of, you know, multiple reasons, but mainly because it's a very robust community and library as well, and makes it fairly simple to translate datasets of various formats into TFDS. Um, so yeah, so our code base also gives you the option to kind of like translate it from any format to TFDS. And, you know, these are just some useful links. You can find our multi-net repo. Uh, you can find the entire code base, all the issues, what we've worked on, what we're working on. and the final V0 list, which is basically what are the data sets that are in our version 0 of Multinet. And also like the deep dive doc that Sid just shared, because it kind of shows like our thought process about how we basically rigorously tackle each aspect of these research efforts. Yeah, we can go to the next slide. Yep. So since we got done on like the consolidation front, what we've been working on most recently is designing this benchmark around this around these data sets and this and our thesis. Um, so we do want to provide like a unified benchmark to evaluate all the existing closed source, open source models that are really highly performant across a wide variety of these tasks that we just mentioned. So, how good are they at navigation-based control? How good are they at, visual question answering? Or how good are they on image captioning and, manipulation-based control? And so basically, you answer questions like, okay, how good are these LLMs and VLMs really when they adapt to action trajectory tasks, be it robotics or reinforcement learning? And the other way around as well, like a lot of the new VLAs, like Octo, OpenVLA, and Google Research's RT1, RT2, they've all been optimized for these action trajectory tasks. Are they really good at image understanding, language understanding, the association of vision language? Um, and we really do want to showcase to the field that there's this like new paradigm and new class of foundation models that are yet to be built, uh, kind of paves way, for this. And we also believe that when this like new type of foundation model is trained in all these variety of tasks and modalities, it will really unlock a great foundation for the agentic capabilities that everyone wants to see right now, especially with you know the progress that the generative AI field has made recently. Everyone wants to like build autonomous agents that can complete workflows, tasks, take actions, whatever it is. And we really want to show that for that to happen, it has to be truly generalist. And with this benchmark, we kind of show how generalist like the current generation of state of the art models are. And Sid, actually, can you pull up the benchmark design, Doc? Yeah, so the way we've been like going about this, like our benchmark is we've tried to identify tasks that we can evaluate the models on that correspond to like these different category of tasks that our data sets are bucketed into. So for vision language, what kind of tasks do you want to evaluate them on? What is the current state of the art? Um, what are a lot of like the popular multimodal benchmarks using? What are a lot of the state of the art models evaluating on? So can we find tasks that are exactly that, similar to that? So for example, for image captioning, we have like a few tasks and data sets, and the next step is basically finding metrics that correspond to each of these tasks and data sets. We also do want to do some research on like composing these metrics because we think a very coherent way of like like showcasing the results of the benchmark would be category-wise metrics, or maybe even a unified generalist metric for the entire benchmark. So, that would give a much more clear signal on how good these, the current class of foundation models are, how good are they in image captioning, or how good are they in image understanding, or, navigation-based control. And then maybe, if we're able to find a way to compose all these categorical metrics, how generalist are they truly? And as a part of this, we've also reached out and are, we are still reaching out to like a lot of benchmark design experts, authors of like really popular benchmarks, a lot of very accomplished researchers who work in this field. So yeah, our next big output will be, benchmark for Multinet, and this is what we're currently working on. You can go back to the slide. Yep. Next slide. Yeah, so this is where we're at with Multinet. We're very excited about this project. We've just consolidated this large data set. We've open sourced the code base that allows you to do it as well. And we're pretty close to coming out with a benchmark for this too. And if any of you find any of this interesting, want to help us build this, help us go in this like entirely new research direction, there are several ways in which you can contribute. Of course, like any open source group, we have our open issues on our GitHub, and especially the ones that we tag as help wanted. They may not be tasks that we immediately tackle, but we do want to do it in the near future, or some of them even in the longer term. So if you find any of those issues interesting, you know, we'd love to, have you contribute. And we're always looking for either, even if it is a short-term issue, longer-term issue, we're always looking for collaborators. We are an open source group. Community is our biggest strength. And also, like I mentioned earlier, we build completely in public. All our discussions, all our thought processes are on Discord. So you can always contribute to our research decisions. Any ideas, thoughts that you have around some of the stuff we're discussing. And you must have also seen that we discuss a lot of like, new releases and the state of the art research that, that keeps coming out, especially in AI. The frequency at which it comes out is so high. So we're always discussing these works, and especially those that are relevant to Multinet or any of our other projects. So you can always, drop any new research that you think is interesting, discuss it with us. And finally, if you really want to be like, a pivotal part of this research, kind of be part of like the decision making process and really help us drive it forward, you can always apply to join our core research team on that link on our website in the opportunities page. And finally, of course, like if you want to specifically reach out to any of us individually, especially about multinet, you can reach out to me, Santiago, Kyle, or Harsh. Uh, we've all been working on this project, and we will be driving it forward. So we're always happy to help answer any questions. Yeah, excited to see you guys collaborate.
Awesome. Thank you, Pranav. So real quick, I think this is a great segue to also mention. So you can see that we have it written here, collaborator and sponsor Medarc. So Medarc is the spinout that I was mentioning earlier. So as sort of as a research group, we've had our first spinout, and Pranav and I actually work there full time. So Medarc is kindly sponsoring our work and is subsidizing a lot of the sort of research cost and some of this stuff, and is also a partner on some other projects as well. Cool. Let's go ahead and go forward, Sid. Awesome. So I'm going to build on the natural question that emerges after you hear about this incredible benchmark to assess this new class of models we think is going to exist, and all of their amazing capabilities and everything Pranav just mentioned is, well, who's building those models? Can we go to the next slide, please? So, the history that Pranav touched on is like all the way from models like Gato a couple of years ago to today. You're seeing a lot of these robotics foundation models. So the idea is, can you train on a ton of language and text and language and vision, and also on control, robotics, reinforcement learning, and get these general purpose foundation models for lots and lots of action tasks, control tasks. And so a lot of groups have started to pursue this. Google has been doing a bunch of work in the form of, with various collaborators in the form of RT1, RT2, OpenVLA. Covariant has been working on supposedly RFM1, and there's been other projects like Octo and several others. So it's an exciting space to train on all of these modalities, but especially on control. And it's something that we're thinking a lot about too. So do you want to go on forward? In fact, we think that this is the basis for a lot of future potential, because what you're essentially doing is you're trying to imbue, reliable knowledge of the world and forcing models to be able to interact with that world reliably. And so that's useful in a huge array of these sort of thematic research directions that we're starting to pursue. So these are very high level, but it sort of gives you an idea about that synergy between different topics. Seth, can we go to the next slide? And so I just wanted to mention that, like, for a while now, we've been working on this project Neko, and it's gone through a couple iterations, and our own understanding has shifted and improved considerably. And so we are tackling this problem as well. In fact, we're designing this benchmark to hopefully be able to effectively assess and build a model that can do all of those tasks. So tons of different robotics tasks, tons of different control tasks, 2D reinforcement learning tasks. And we think it'll be an enormous capability jump over what exists today, and it'll be the foundation for an entirely unexplored class of approaches. But it will be very sort of difficult to pull off, and will require lots of data, and that's why we've assembled this data set as a starting point, and we hope to engage with the community. So keep an eye out for the models that we plan on releasing as well, in addition to, of course, the profiling work that Pranav said. So we'll have some updates here very soon. Um, Next slide, Sid. Yeah, I'll also briefly touch on. Let's go ahead and go one more. Recently, we had an interesting paper. So our sort of agents research initiative had put out this position paper covering what we think are opportunities and limitations in LLM agents, and we'll talk about how our group is addressing this in a bit towards the end of today's session. But it's a cool paper. We're big fans of our work, so definitely go check it out. There's information here. We can share it in the chat as well. And we really discuss the opportunities and limitations when you see how agents are being designed and what people are calling agents, likely as the result of LLMs and their sort of ubiquity and capability and the generality of language. You see that people are tackling memory, decision making, and reasoning, things like tool use, which we're really interested in, continual learning in an LLM centric way. But there's also challenges there, and there's limitations there, and we suggest that this paradigm of linearly sequential language generation can limit a lot of the downstream reasoning that you expect these models to be, or excuse me, these agentic systems to be able to do. And so, yeah, we can discuss that. So definitely check that out. Next slide. Cool. I think this is all you, Helen.
Actually, this is starting off with my update.
Sorry. Go ahead.
Yeah, so we're very excited to announce our new cooperative robotics direction, which we kicked off recently. So Manifold is also expanding into robotics research, and those projects are being headed up by myself and by Helen. This project specifically is on cooperative robotics. And so cooperative robotics essentially means multi-agent robotic systems cooperating on a given task. So as you guys are aware, robotics are embodied AI. They are sort of the testing ground of a lot of AI technologies, and a lot of recent developments in AI have been in robotics. It's sort of the next frontier for performance of these models to be tested. But it comes with a large set of real-world challenges. There's noise in robotics, there's disturbances, systems have actuation, performance limitations. You never have the complete state information. Any state-based representation of the system is always some sort of compressed representation, a lossy representation of the real sort of rich amount of information that determines the performance of that robotic system. So robotics is hard. And multi-agent robotics is harder, but it has certain critical advantages over single sort of robotic architectures. Those being robustness to individual failure. In a multi-agent system, if it's designed well, then there's no single point of failure the way there is in a monolithic sort of system. Multi-agent systems can also collaborate on given tasks, and they can parallelize given tasks. So they have certain advantages that make them very attractive for many deployment scenarios. But they come with their own challenges, namely communication and even more incomplete state information than singular robotics scenarios. So the goal of the cooperative robotics project, right now we've launched it as a reading group. It's in an exploratory capacity. We're sort of fleshing out these different directions that are really, really interesting and promising. Those are applied as well as theoretical. Briefly, I'll touch on an applied direction. That's what we're starting with. And then I'll also talk about a few theoretical cooperative robotics sort of directions that we would like to take this project in the very near future. Okay, so a use case that's very near and dear to my heart, it's what my own PhD research is about, and it's what we'll start with here with the cooperative robotics project at Manifold, is space robotics. So space is a very unique environment. Ground-based robotics have been developed. There's a very rich literature base for ground-based techniques, but in space there are a few unique constraints that introduce differences that cannot just be easily bridged to. So it requires some new consideration, some new sort of research, and particularly it lends itself well to data-driven techniques because of the lack of complete information as well as the adaptivity requirements. So some of those things are compute restrictions, onboard compute for satellites or space robots. Not only are limited by weight requirements that prevent large um, computationally powerful systems from launching, uh, but also the underlying sort of compute infrastructure of satellites and therefore space robots has to be robust to radiation. And so it's a different kind of chip, basically. It's a less efficient kind of chip that's more robust to these sort of events, these cosmic radiation events. There are also fuel restrictions. Fuel is very valuable in space because refueling is very difficult. There's unique dynamics, of course. These are things in orbit, so there's orbital dynamics rather than um, ground-based. There's basically no friction and no gravity, which introduces unique sort of requirements on the system. And then usually in most aerospace applications, there are very stringent safety requirements because this is not only the domain of critical infrastructure like internet infrastructure and communications technology, it is also uh, sort of a tactical space where governments have a lot to say about space. And if something goes wrong, if your country does something wrong, then other countries are not happy with that. So there are very stringent safety requirements with any sort of space mission. However, we believe that the development of robotic systems for on-orbit servicing is critical for human habitation and exploration of space. Autonomous systems that basically make safe a space safer, cheaper place to be are going to be crucial in getting us out there, essentially. And so this current project is to explore the autonomous assembly of large-scale space structures. And yeah, that's kind of what our current work is on the cooperative robotics direction. However, there are several open areas for cooperative robotics that we would like to address. These are like theoretically open areas. Um, so one of them is swarm adaptation and transfer learning. Uh, Developing adaptive swarms which can learn from the experiences of single agents is a very large like technological unlock. It's similar to biological mechanisms that we see in bugs and birds and other organisms. And it can create adaptation to out of distribution changes, things that are unexpected. So that's a very interesting area that we're looking to uh, expand into and explore. And then there are two other areas that are also salient right now. One of them is learned interagent communication. So robots learning better ways to speak to other robots. This could limit adversarial attacks. There's work on selective attention, so only paying attention to uh, other agents that have something sort of valuable to say. And then also the current sort of way that communication protocols work is fixed in multi-agent systems, but making it adaptive or learn could improve cooperative performance. It may be better to not listen to other agents or to not relay information to other agents at a given time. So that's quite exciting as well. And then possibly the biggest fish here would just be massive multi-agent deep reinforcement learning for multi-agent systems. So um, DeepMind actually showed recently, well, not recently, in the beginning of 2023, they showed that foundation scale deep reinforcement learning could exhibit open-ended autonomy, which is very exciting. And this is sort of another path towards generalist robotics, along with some of the techniques discussed with Neko and with Multinet. This is like another way, massive deep reinforcement learning. So it's all very exciting stuff. These are areas that we would like to expand into in the near future, and we're exploring these. If you're interested in joining this project, feel free to apply. I would love to have you and to discuss. We're in the very nascent stages here. Okay, Helen, if you would come to the stage.
You guys hear me?
We can, yes.
Okay, great. So, hi, I'm Helen. I'm currently pursuing a PhD in human robot interaction. I have a background in psychology and cognitive science. So, I am very interested in cognition in robots. And today we'll talk about metacognition in robots. Next slide, please. So, what is metacognition? Simply put, it's thinking about thinking. And in humans, metacognition can typically be broken down into two components: metacognitive knowledge and metacognitive regulation. So, metacognitive knowledge is typically broken down into three components. On the very left here, we have knowledge about oneself as a learner. So, this is things you already know, things that you don't know, gaps in your knowledge. So, knowledge about gaps in your knowledge. And then we have procedural and strategy knowledge, which is how to do things and strategies you can use to learn things. And we have conditional knowledge, which is what strategies to use and when and how. So on the right here, we have metacognitive regulation broken down into planning and monitoring of task performance and evaluation of learning. The planning, it typically has to do with planning on the allocation of cognitive resources. And when you're performing some task, you typically need to monitor how you're doing. And if learning is required, you would need to evaluate your learning progress. Next slide. So, what the hell is metacognition in robots? Well, we don't know yet. So, research on this topic in the past few years has been pretty scarce. And my guess is it's probably because cognition in robots is not a solved problem yet. If cognition is not a solved problem, it would make sense that metacognition is also not solved problem. Next slide. So my preliminary observation is that in cognitive robotics, with software architectures that have a clear separation between the perception layer and the reasoning layer, this is what you typically see in papers that claim to have metacognition. So you on the left in the left diagram, you see on the very bottom, you start with a perception and actuation layer that typically just directly interfaces with the real world or a simulated world, and you have information passing to and from a planning and or a learning layer. You also have information passing to and from that layer to a metacognitive monitoring and control layer. So in the middle, this is an example Minecraft game scenario. It's called gold hunting. On the right, so you see a separation in the middle. On the right is the original task where the Minecraft agent is looking for the gold block and trying to retrieve the gold block. So it just randomly explores the environment. Once the gold block is sighted, it tries to do some path planning to go to the gold block and get it. On the left, you see a variation of that task where there's a glass door between the two rooms blocking the agent's path to the gold block. So the agent is still able to see the gold block, but after it does the path planning, it will somehow be blocked and not able to get to the gold block. So the excuse me, the architecture proposed in that paper starts with this on the very bottom in the right diagram. Starts with this perception and actuation layer. And then it passes objects observed to the planning and the learning layer. The learner is a tabular Q learner. And then it has a very metacognitive monitoring control layer that sits on the very top. So what this metacognitive layer does is it compares expectations given to it by the planner. So the expectations are basically what's expected to be observed once an action is executed. And the metacognitive layer compares that expectation to what's actually observed. In other words, the percepts from the very bottom layer. And once there are discrepancies, and the metacognitive layer knows that there's a novelty in the world, so then it spawns a learner, a RL agent, to then accommodate this novelty. So the metacognitive layer also designs a reward function for the RL learner. In other words, the agent will realize, okay, there's actually a glass door, something blocking my way. I need to learn the action to break it down, and then I can resume my path planning. Next slide. So if you can play the video on the right, this is another example of a robot brain where the planner is replaced with a large language model. And on the right, you can see the human says, can you bring me a soda? And the large language model plans and comes up with actions, a sequence of actions the robot can take to actually get the soda. So now the human here is trying to be a jerk and then trying to not let the robot get the soda. So the robot also has some success detection to say the action that I wanted to execute was not successful. So the robot then describes the scene. It says, I don't find the Coke, but I see an orange soda. And then it asks the human, there's no Coke, but is the orange soda okay? And the human says, no, please bring me a lime soda. So then and the action output is first to find the lime soda, and then the next action would be to pick up the lime soda. So in a robot brain like this, it's unclear whether there's a metacognitive layer. So the question here would be, since they're using a large language model, can you prompt some metacognition out of this robot brain? Next slide. So yeah, as mentioned earlier, there's been a lot of hype around end-to-end deep learning large VLAs. This is Google's RT1. So in a robot brain like this, instruction and images go in, and then robot actions directly come out. In something like this, everything is kind of mushed together. So for something like this, the question would be, can you train metacognition into something like this? And what would metacognition even look like for a model like this? And then another question would be maybe come up with a benchmark data set to measure and assess metacognition, if you claim that a model like this has metacognition. Next slide. So this is a very new project that I'm starting. The current directions are I'm basically doing a literature search, and the output from that is potentially a survey paper on metacognition in robots. But my real goal is to actually, through doing this literature search, to find a metacognitive toy problem, and then have a formal definition of that problem so that we can actually find a solution and demonstrate an algorithm or a neural network that we train for this problem. If you are interested, you have my Discord and email. Feel free to shoot me an email, send me a message, and we can happy to discuss further this topic.
Awesome. Thank you, Alan.
Yeah, Helen, that was awesome. Okay, cool. I'm gonna go. I realize we're actually running out of time here, so I'll go a little bit quickly. But this section is basically an opportunity. Oh, can you go back one slide? So, just for us to chat about things that we are planning on spinning up soon as we build conviction. So as you can see that, we sort of take things in a meticulous way, and we basically focus on exploring the space as we build our sort of hypotheses. We have domain experts, and we really start to explore it. And so right now, we're starting to explore tool use, foundation models for biology, which is a very broad mandate. And then we have a couple of thematic areas that are more sort of topical that I'll talk about very briefly. So, one slide forward, Sid. So one of the things that we really feel strongly about is that a big part of realizing agents is realizing tool use in these models. One slide forward, Sid. So you hear tool use bandied about in a lot of different ways, and it's sort of semi-rigorous in the different ways it's discussed. Mostly both in industry and occasionally in research, people refer to function calling as tool use. And at a high level, function calling is where you get an LLM to sort of spit out structured um, parameters and information to be passed to specific API signatures that you give it context for. And there's been a lot of great work on this from teams like Cohere, from OpenAI, and also from open source efforts like the Gorilla team at Berkeley. But we think about tool use a little bit differently. If you go one slide forward, Sid. We think about tool use as actually analogous to the VLA question. So if you think about, for example, you saw some of the demonstrations Helen was talking about and what Pranav and I were discussing a little bit earlier. Robots and sort of the embodied agent problem forces reliability in tons of different interaction scenarios. And we think of digital tool use, meaning enabling AI systems to be able to operate, for example, software on your computer in a similar way to you, and being able to do so over long horizons of task completions. We think about that in a very analogous way. And in fact, we think of VLAs as a starting point for these trajectories of tool use. And we're defining tool use a little bit differently. And we're starting to think about how the VLAs that we're building and the VLAs that others are building can be used towards this objective. Next slide, please.
Harsh, we're getting some messages saying that they're not able to hear you in the chat. I'm not sure.
Can you hear me?
Eric says he can. Yeah, I can hear you. Other people, okay. Okay,
let's
cool.
keep going.
Yeah, we'll keep going. Sorry about that, guys.
Something weird might be happening. Not sure what's going on. But we'll just push forward, I guess. So this is sort of a visual that kind of explores how we think about this. So if you think about actions in that analogous sense, you start to see it map quite closely to trajectories of interactions. And in the case of software, that might be interacting with APIs, that might be interacting with in a vision-based way, sort of how you may have seen the work that Adept AI used to do earlier in the year and in the past couple of years. And so we're thinking in sort of a trajectory-based approach for this action problem, and we think that maps to effective tool use really well, and we think that is sort of a core capability for agents to effectively be realized. So we're really excited about this direction. Next slide, Sid. And it's something that we're planning on rapidly spinning up capabilities around. So if you are interested in this problem and you want to touch everything from the VLAs that we're working on all the way through to this new perspective on tool use, establishing benchmarks and perspectives here, and building these actual models that we're hoping to get to, we are actively recruiting. This work is also sponsored, and we have a lot of resources to tackle this. So definitely reach out if you're interested. The other thing I wanted to touch on briefly is this is even earlier stage than the other things that the group is talking about, but we are planning on spinning up a reading group in understanding foundation models for biology. And this is one of the sort of AI for science thematic projects that we've been thinking about for a while. There has been recent work that shows the effectiveness of large-scale sort of foundational training, lots of pre-training, in biology problems, and then fine-tuning to effectively completing various downstream objectives. And so a bunch of these figures are from various works. So the three on the, or the two on the left, and then the sort of cartoon on the bottom, all are from the EVO model that was a sort of I believe it was DNA, RNA, and protein trained foundation model for biology. And then on the right, you have ESM3, which is a frontier generative model that's capable of reasoning for proteins, but across different biological properties of them, sequence, structure, and function. And we really think that, like, it sort of the capability of deep learning systems has proven itself in biology already, and we think that going forward, more and more complex objectives will be, at least sort of accelerated, and that these models that people are building in sort of an analogous way to the ones that we're talking about in our more fundamental approaches will be really useful to designing entire suites of platforms that may help you design organisms from end to end, which have numerous sort of useful capabilities downstream. And so we have a bunch of biologists in the community, and we're really passionate about this problem. So we're starting to explore this. So if you're interested in joining the research group and maybe participating in our initial sort of surveys of the field and seeing what the opportunities there are and how we might formulate some different projects that we're thinking about, please reach out to me. Always happy to work with people on this, and this is something that we expect to be putting a bunch of resources in the medium term towards. So, next slide. Yeah, I'll be very quick here since we're almost out of time here. We're always exploring a lot of fundamental ideas. So, we're always thinking about new architectures of primitives. We're thinking about new learning capabilities in a lot of the models and technologies we're building, and these ideas intersect with each other. But these are sort of bigger themes in our focus, and so. Realizing these architectures, these new learning rules in autonomous agents is a core focus of ours, and we think that'll unlock a lot of amazing stuff downstream. So if you're interested in these topics and things, and you just want to get involved, discuss, we have a lot of different sort of smaller projects in these areas as well, and we're always happy to do so. And we're always thinking about applications as well. Next slide. Cool. I think this is you, Sid.
Yeah, so just to cap it off and give a couple of org updates. So along with the research project updates that you've seen in the presentation so far, the organization is also growing. And so the first thing that I want to say here is that teams are recruiting. Our operations team is recruiting, for example. We organize the externally facing materials like the research log. We also organize these events like the CRC and other upcoming events, which I'll talk about in a second. Um, and we also do a lot more. So if you're interested in joining the operations team, please feel free to reach out. There are also materials on operations team expectations and an application as well. Um, the project teams, as you saw, are also recruiting. Each of them had these CTAs in their section of the presentation, but I wanted to recap it here. Multinet, NECO, our cooperative robotics and metacognition projects, as well as tool use, are all recruiting. So we would love for you guys to apply or at least discuss and check out the GitHub and contribute to the conversation and join the effort. And then we're also excited to explore our emerging focus areas. So if anybody is an expert in any of the emerging focus areas that Bert just mentioned or is interested in them, feel free to talk and we'll engage with you. We're excited to discuss those things as well. So all teams are recruiting. We also have new events. So you see here the community research calls. This is our second one. This is Manifold's public-facing presentation of updates. We've successfully launched this. This is the second one, so I would call this launch successful so far. Of course, we're always improving, and we will continue to improve this event. By the way, if you guys have any feedback, please feel free to drop it in the Discord. We have a feedback and suggestions channel. We would love to hear it. But also, very excited to announce that we are working on a hosted talk series, and we're going to launch that in the very near future. So please stay tuned for updates there. Those are talks where we're going to invite people to speak to the Manifold community about cutting edge research related to our projects or related to other areas that we find very interesting. So yeah, it's very soon to launch. Stay tuned for updates there. You'll see them in the near future. We are also planning on launching some reading groups. These will be more frequent events, more casual events where interested members can discuss specific paper releases. So we're also working on putting that together. So stay tuned for that as well. And if you want to get involved, you can feel free to subscribe to our research log. It's the subscribe button is like this big button on the bottom right of our website. You can join the Discord. If you're here, you probably have already joined the Discord. And you can check out our GitHub to see our ongoing work as well as open issues. And then finally, if you are interested in working very closely with us, you can join the OS research team. So feel free to apply. I will provide all links in Discord after the call. Everyone, thank you so much for attending today. Thank you so much for attending our second community research call. Arch, any words?
No, yeah, this is awesome. Thank you, everyone. Really cool to see you all, and yeah, please feel free to get involved. Oh, one last thing is that if you have an idea around a project and you want to get Manifold support or sort of become more involved in Manifold towards that project, we have an established project proposal pipeline, I believe, as well. So we'll leave links and stuff for that too. So great, awesome. Have a great Sunday and a great week ahead. Thanks, everyone.
Yeah. Thanks, everyone.